what is Math Scholars? It's our 4.1 to 4.4 study guide. Now this quiz is on Polaris. You wouldn't be drawing any graphs on paper, but you'd have to be answering questions about these graphs. So on number 1, the starting point is 2. The growth factor is 4. They could definitely ask questions about that. I've already put it in my calculator. So let's take a peeky at the graph. Now notice it's skirting along at 0. That's because we have this asymptote right here. I don't know why my graph moves every time I try to draw on it, but basically the asymptote would be at y equals 0. It's still moving. This is very weird. The second time this has happened now. I'm just drawing my graph like this. There we go. The domain, so my asymptote should have been at y equals 0. Sorry about that. The green line can be my asymptote. I'll get rid of this one. My line itself is going to come on up, cross through there at the starting point 4. That's going to make the domain negative infinity to infinity and the range 0 through infinity. Now this is exponential growth because like I said, that growth factor is that 4. Oh, the starting point was 2. I think I'm so distracted by that graph like moving along like a ghost. The starting point should be 2. Let's take a peek. Yeah, starting point 2. If you want to take a peek at the table, let's scroll up a little bit. It's going to be 0.03 for the first entry. That graph is still just moving around like a ghost. The second one is 0.125. The third one is 0.5. And then 2, and then 8. It's just getting times by 4 each time. 32. And finally, 128. I do not know why that graph just keeps moving. Let's go to the next slide and see if my graph can behave itself. It's moving right now, and I'm literally not touching it. Second one, this time our starting point is 10, and our growth factor is 1/2. So this will be decay. I know that before we even start. There is going to be a 4-unit right shift and a 3-unit up shift. It's the up and down shift that will move our asymptote. So before I even begin, I know my asymptote will have been moved up to y equals 3. All right, let's put it in and see what it looks like. We've got our 10 first, then our 1/2. I'll just do 0.5 to the x minus 4 power. And then the plus 3 has to be big again. Yeah, so it definitely went right and up. It's kind of over, not really showing up on the screen hardly at all. That makes your domain negative infinity to infinity, but your range is only going to be 3 through infinity because that upshift. When we look at our table, it's going to start real big and then just start shrinking. So 1283. 643, 323, 163, 83. I can't write small enough with this marker. 43 and then 23. We're still doing graphs, but this time we're doing a log graph. This graph would have a 4 left shift because of the x plus 4 in the parentheses, but no up or down shift. Let's go ahead and see what it looks like. You can just use your regular log button on the home screen because it would be a log base 10 unless it's otherwise stated. Oops. Now with log graphs, we oftentimes in our table see errors because you cannot take the log of a negative number or a 0. If you scroll this way, you do see some errors. Now luckily, because of the way our shift is, we are not going to have any errors on our table. It'd be 0. And then 0.3, that's a 0. And then 0.47, I'll just go 0.5. And then 0.6, 0.7. I'm just rounding. 0.8 for 2. And then for 3.845, so 0.85. Let's take a peek at the graph and talk about where the asymptote would be. It's a left-right shift that moves our asymptote, and since we have a left-4 shift, our asymptote moves to here. At least my graph is not moving itself. The asymptote would be x equals -4. So our domain is -4 through infinity, with the range -infinity to infinity. All right, this log graph has no vertical shift, no horizontal shift. So the asymptote's still going to stay at 0, 0. It has a vertical shift of 2 up. So no left-right shift, but 2 up shift. Let's get it put in the calculator, take a peek. Now this is a log base 4, so you can do math up, 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 or math alpha math is another way to grab that button. Make the log base 4 of x plus 2. And that's what it's going to look like. Just kind of starts here and grows. It looks like it stops here. It will continue along that asymptote. There goes my graph, just moving all around by itself again. I must bump something when I use the stylus to write. My asymptote will be at x equals 0, making the domain 0 through infinity, in the range -infinity through infinity. The graph's just going to keep on moving. Oh, I almost forgot about my table. Let's see if we have any errors. Yep, we sure do. We have errors all the way through 0. I'll just, there goes my graph over here. And then at 1, it picks up at 2, 2.5, and 2.8. 2, 2.5, and 2.8. All right, we're moving on to investing money. There are several equations up on the board that will stay up on the quiz day. In fact, this is an open note quiz, so any formulas you have written down you can use. You can use the study guide on the quiz. Thomas is investing $10,000. That's our starting amount of money. He's compounding it daily, so we will want the equation with an n value in it. The n value is daily, so it'd be 365. And then the 365 goes here times the amount of years, 19. Let's go ahead and get this typed in. I'll just use my one on my desk, so I don't need to get my big calculator up. 1 plus 0.054. Hopefully I don't make a mistake here. Divide by 365 because it's compounding daily. Then 365 times 19. I got $27,000, 896.72. So this is your answer for part A. This is the answer for part B. I'm not even going to try to squeeze it on that blank. Number 6, she's compounding semi-annually. That's an n value of 2. So 1 plus 0.12, that's for that 12% interest rate. Semi-annually is 2 times per year for 30 years. That's your answer for part A. Now your answer for part B, let's type it in. 560, 1 plus 0.12 over 2 to the 2 times 30 power. I got $18,000, 473.11. Okay, this is interesting. It's not money, it's objects, but we are going to use the exponential growth model, which is this formula. We are starting with 25 mice and tripling each week. So there is your setup. How many mice will there be in 15 weeks? By the way, this is the equation I would put on answer blank A. For answer blank B, we're just going to do a calculation. We will put a 15 in for x, because that means it will triple 3 times, or 15 times. It will triple 15 times. Oh my gosh, this answer's huge. I might not have enough space to write it. 3, 5, 8, 7, 2, 2, 6, 7, 5. So if you get a really big answer, don't be alarmed. Things just grow really fast when it's exponential growth. We don't want this. I don't know what that is. A minivan, we're depreciating now. Let me give you the depreciation formula so you can remember. It's starting point, and then 1 minus the rate of depreciation to the x power. So for this one, we are starting with $32,000 for RBM, depreciating 0.15 each year. It looks like how many years are going to go by? 7 years. So I'll put that in. That's your answer for part A. And part B, I'll type it in my calculator. $102.58.47. All right, looks like he's compounding continuously. We have a special formula for compounding continuously called PERT. Now, E in this formula is just the E button on the calculator. Maybe I'll type this one in with you guys so you can see. 6,500 to start, and then our exponent will be that 0.075 to 7 times, looks like he's doing this for 22 years. So let's type it in on the home screen. 6,500. The E button that I like to use is second ln, right there. It's in, oh, didn't come up. 6,500 second ln. There it is. 0.075 times, I forgot how many years. Was it 22? Yep, 22 years. 33,000. 33,845. 33,845.37. I do not like writing with this stylus. That's how I have to do my videos now. All right, we're just using the law of exponents. We're not going to type these in and get any decimals. 12 divided by 2 gives me 6. 12 divided by 2 gives me 6. There we go. And then E, for my E's, I have to do bigger minus smaller, put the answer where the bigger was. So 15 minus 12 gives me the 3. I put my answer down below. Now this is a square root problem, so keep in mind there's a little 2 there. The square root of 16 is 4. 8 divided by 2 is 4, so it'd be e to the 4th. Finally, this is going to square my 4 and give me 16, and then those two are going to multiply, so 16 e to the 4x. On this slide, we get to use our calculator. So on 11, you can use that E button I showed you a couple minutes ago. It says round your answer. It doesn't say to round, so just get a decimal answer. 162,754. 0.79. I just like hundredths unless they tell me otherwise. E to the negative 4.2. 0.01499. And then finally, I'll just do this on my other calculator, 1/5. E to the 1/2. I got 0.33. I rounded that. All right, these are my favorite. We're going to use exponential form to solve these. Left, right, center, or base exponent answer. The 5 is your base. The 4 is your exponent, and the x is your answer. So it's almost like a crisscross motion. 5 to the 4th, that's pretty easy to find, is 625. And this one in exponential form, it'd be x to the 4th is 16. So we can use the 4th root to solve. Now you cannot have a negative base for a logarithm, so we only want the positive answer, 2. And finally, 2 to what power is 1/4? So you can experiment with this or write it in matching bases. And I like to write it with my matching base. I know that 4 is 2 squared, so I could just flip it and make it a negative. So 2 to the negative 2 power would be 1/2 squared, which is 1/4. that means x is negative 2. And finally, my favorite, finding inverses, switch the x and y, then resolve it. So here's my switch step. My resolve is so easy on these. You just put them in exponential form. Log graphs, log functions, and exponential functions are inverses. So if you start with a log, you'll end with an inverse, or you'll end with an exponential after doing the inverse. To put this in exponential form, I'm going to use 3 as my base, the x as my exponent, and the y plus 6 as my solution. So base, exponent, solution. We are solving for y, so we want to finish by subtracting 6. So here is my inverse, 3 to the x power minus 6. And I think that is it. So thanks for watching our video. It's an open note quiz. You can use your study guide or your notes. So that's exciting. Everybody should do well on it. Bye.